Okay, so this is question 7 of the A-Level 2023 paper 3. And this is about a car is moving horizontally in a straight line with velocity v. We're given an equation, and it's a equals v lots of 8t over 7 plus 4t squared minus a half. Now this still is in the pure section, but it's to do with acceleration velocity. So it's kind of it's kind of a nice link between the pure and mechanics paper, really. So, part A, find the times when the acceleration of c is 0. So if I want the acceleration to be 0, this just means a equals 0. So in other words, 0 is v lots of 8t over 7 plus 4t squared minus a half. Now, we've got two options here. Either this can be 0 or this bracket can be 0. If I'm just scanning the question, I can see v has to be bigger than 0. So that's not possible, which means it's the other one. So this here has to be 0. Okay, that means that 8t over 7 plus 4t squared has to equal a half. And then cross multiplying, I'm going to get 16t has to equal 7 plus 4t squared. And so gathering everything to one side, we get 4t squared take away 16t plus 7 equals 0. Now, hopefully this one factorizes. If not, you can shove it into your calculator. But I can see we're going to get a 2t minus 1 and a 2t minus 7. Just double check that. Yeah, that's good. So this means t has to be a half, or t has to be 7 over 2. So 0.5 and 3.5 seconds. Okay, so that's part A done. Okay, for part B, it's a differential equation question. So let's give it a go. Looks like we're given some initial conditions here. So when t equals 0, we're told that v is 17.5. And when t equals t, we're told that v equals 5. Now the tricky part about this is you need to remember that the acceleration is dv by dt. Okay, otherwise you're going to struggle to set up a differential equation. So that's the first thing I'm going to do. I'm going to write dv by dt equals v lots of 8t over 7 plus 4t squared minus a half. And you can see it's kind of looking a little bit more like a traditional differential equation now. So now we're going to separate. Okay, I'm going to divide both sides by v to get 1 over v dv. And I'm going to multiply both sides by dt to get 8t over 7 plus 4t squared minus a half. And this is all multiplied by dt. Okay, the next step of a differential equation is to integrate both sides, like so. And for this, I will come up to the top here. So, integrating 1 over v, we get the natural log of v. Now, again, just because v has to be bigger than 0, I don't actually need the modulus signs here. You wouldn't lose marks if you did put them there. Okay, this term here. I'm looking at this term, it's a fraction. Usually, fractions are going to integrate to some kind of ln, and I can see that the denominator differentiates to the numerator, so it's actually perfect. We're going to get the natural log of 8t over 7 plus 4t squared. Sorry, my bad. It's not going to be the natural log of 8t over 7 plus 4t squared, it's just going to be the natural log of the denominator. Like so. That's better. And then minus a half just goes to minus a half t, and then we've got a plus c. We only put a plus c on one side because if we do both sides, it'll just get absorbed into one anyways. Okay, I'm going to plug in my initial conditions. So we're going to get the natural log of 17.5 equals the natural log of 7 plus c. That's my first condition. And so this tells me that c is the natural log of 17.5, take away the natural log of 7, and we can now use log laws to combine them like this. And then 17.5 over 7 is the same as 35 over 14. So there's my C. Okay, so second condition is when t equals t. We get v as 5. So the natural log of 5 is the natural log of 7 plus 4t squared, capital, minus t over 2, plus the natural log of 35 over 14. Okay, we are nearly there now. Let's move that minus t over 2 onto one side and the logs onto the other. So we're going to get something like this. So plus ln of 35 over 14, and then minus ln 5. Okay, brilliant. I'm just going to need a touch more room here. So we'll come over to here. Which is not letting me do that. Okay, not to worry. We'll figure it out. So if I multiply both sides by 2 now, no, in fact, I'm not going to multiply by 2 yet. I'm going to combine all of the logs first. So, ln 35 over 14 minus ln 5, that's just going to go to ln 35 over 70 because you divide. And 35 over 70 is just a half. And so when I combine all three of them, I just get ln 7 plus 4t squared over 2. And then you can see the last step is just to times by 2. So we've got ln 7 plus 4t squared over 2. And that is exactly what we wanted to show. Okay, let's move on. Right, part C. Use an iterative formula based on the equation in part B to find the value of t given your answer to 4 sig fig. Use an initial value of 11.25 and show the result of each step. So just a reminder what t is. T is when the velocity is 5. So somewhere, I guess along here. All right, so what was the formula? It was t is 2 lots of the natural log of 7 plus 4t squared over 2. So how can we make this into an iterative formula? Well, let's call this t to the n plus 1. And let's call this tn. So we were told to use t0 is 11.25. Now a really good hack is to just put 11.25 into your calculator and then press equals. So that's now your answer. So now you can go to ln fraction button 7 plus 4 answer squared over 2. Okay, press equals, this will give you your T1. So T1, I'm just going to write out the workings for the first one. 7 plus 4 lots of 11.25 squared over 2. And this gives me on my calculator 11.09523. I'm going to press equals again. This time, I'm not going to write the workings, but I get 11.04058. Press it again, and we're looking for convergence, aren't we? So 11.02111. Press it again, we're going to get 11.0141. It's kind of starting to stabilize now. And then T5 is 11.0116. Let's just do one more to check, but I think we're there now. Yeah. So to 4 significant figures, we've got t is 11.01. Okay, brilliant. So the last part then says, find the time taken for c to decelerate from traveling at its maximum speed until traveling at 5 meters per second. So we need to kind of think about what this is here. This is a velocity time graph, okay? Which means if we're looking for the maximum point, we want to know where acceleration is 0. But we've already worked this out, okay? There's 2 points. There's 2 maximum points. Remember, one of them was a half, and one of them was 7 over 2, or 3.5. Now clearly, this one is going to have to be 0.5, which means this one is 3.5. So find the time taken to get from the maximum point to t. Well, we're just going to do 11.01 take away 3.5, which is just 7.51 seconds. Okay, so tough question for the last one of the pure section, but hope you enjoyed. See you for the next one.